Thank you. Professor Kuhlmann, Professor Koh, ladies and gentlemen, the title of my keynote is Lifecycle Management of Infrastructures towards an Integrated Approach of Design, Construction and Maintenance. It's obvious that a keynote of just a half an hour can't address each and any aspect of the theme. We could easily spend a course on that. I therefore selected key issues as follows. First, I will give you a brief introduction to the theme. Subsequently, interaction between disciplines will be addressed. After that, a broader perspective of lifecycle considerations. From there, I will address larger projects and discuss some specific tools. And finally, I will give you my comments. It's my objective to achieve that this presentation serves as a trigger for some of you to further explore the theme and for others to just have a brief overview. So let's get started. Infrastructures are built to serve human society. They should fulfill their intended purpose in an effective, reliable way and be safe for a defined service life. Traditionally, the subsequent phases of realizations are split. First design, followed by construction of the scheme, and finally the operational phase. Due to this approach, sub-optimizations have frequently been observed. Triggered by privatization in many countries in Europe, infrastructural schemes are more often than before developed, constructed and even maintained by private companies. The successful company gets the project awarded through a tender procedure. To be successful, a most competitive proposal must be developed, which at the same time must comply with all relevant requirements. These objectives can only be achieved if life cycle costs are optimized and integrated design procedures are followed. Design engineers should not limit their horizon to design aspects only, but need to consider the service life cycle on a holistic basis. This means that a strong interaction with the other disciplines involved is essential. Apart from the other design disciplines, a close interaction with cost estimation, work preparation, procurement, construction and maintenance is essential. To perform in such environment, design engineers should understand the process they are in and the interactions that should be managed, but also need tools and criteria to make a contribution to the overall process. And that's where the gap often appears in practice. The primary interaction is between design and the functional requirements and boundary conditions on one hand, and design and the execution maintenance aspects on the other hand. But also the interaction between different engineering disciplines should be considered as well as the interaction between design and quality, health, safety and environmental care. Properly performed interaction is a decisive success factor to develop and realize effective and efficient civil engineering structures. From the relatively easy schemes to the multidisciplinary complicated schemes, the same basic principles apply. Design engineers should, as part of the design, identify and optimize the cost drivers of the scheme. The manpower required, equipment needed, material demand, construction time required and the applicable cost related to maintenance and repair. The optimization in this respect is the effort to reach a structural and economically justified scheme that complies with the functional requirement in the most effective and efficient way. During the development of the concept, interaction will generally lead to alternatives. The alternatives may be fundamentally different in the way they cope with the many aspects of the scheme. The choice between alternatives is generally governed by cost considerations. To serve as a reference parameter, cost should be integral total cost. For the more complex infrastructure projects, and especially for through-life approaches, cost as a fixed numerical value does not exist. The complexity of cost components is often to a level that a risk-based approach of cost estimation is required. Such an approach is presently the state of the art. The result of a risk-based cost calculation is a probability density of anticipated cost. And design engineers have a significant contribution to this process, as in design freedom is converted into specifications. And as such process should be performed with through-life focus. As such, interaction is a key success factor. Interaction between design, construction and maintenance is a must to assure effectivity and economy of the scheme. Interaction between design, construction and maintenance is not a well-established basic attitude of individuals involved. To interact, one should have a clear understanding of not just the knowledge domains involved, but also of the driving mechanisms